Oh, there's two sides multiplied.
No, it's
Inside.
The inside,
Oh.
right? Okay, so the area is the amount of space inside a figure, right? Are we thinking two-dimensional or three-dimensional?
Two-dimensional.
Two-dimensional, right? So it's inside shapes, essentially, right? Not inside three-dimensional like our box, right? That'd be a little different. We'll talk about that later on. That would be the what? The volume, right? So when we do the area, what's really important about our answer?
square.
Yeah. So if you don't know that, big old star, the answer, oopsie, has a label that's squared. So it doesn't matter what it is. Meters squared, inches squared, feet squared, right? Why is it squared?
Because it's
Your
they're squares.
What?
You're multiplying.
There's squares on the inside.
You're what?
Multiplying.
Yeah, because I'm multiplying two things together. And if I have inches over here and inches over here and I'm multiplying inches times inches gives me inches squared. That make sense? Okay? So, from here then we start looking at specific shapes. So we're going to look at the area of, our first one is a parallelogram. So what did we learn about a parallelogram the other day?
Has two sets of parallel sides.
Two sets of parallel sides, okay? And what else is true about those parallel sides?
Congruent.
They're congruent, right? So, can you draw a parallelogram?
Yeah.
How do I show everybody in the world that this is truly a parallelogram?
Slashes.
The play buttons
Oh.
and the slashes, right? Now, remember, I don't want the same play buttons on this side, so we're going to use my fast forward buttons. And then we could have our slashes, right? Slash here, and then two slashes here and two slashes here. Okay, so then we went on and we talked about a lot of parallelograms. What were our parallelograms that we talked about?
Trapezoid.
Quadrilateral.
Okay, a trapezoid's a quadrilateral.
Oh, parallelogram.
Square.
It could be a square. What else?
Rectangle.
Could be a rectangle.
Diamond.
Could be a
Rhombus.
or it could just be a parallelogram, right? So we talked about all that the other day when we first introduced it. So remember all those characteristics. So from here, normally when we talk about the area of a parallelogram, what shape jumps into your mind?
Square.
A square or a rectangle, right? Because we're still trying to figure out if a rectangle is a square or a square is a rectangle, right? Square is a rectangle, right? Okay, so how, when you were a little kid, right? You're still kind of little, but you're a little littler. What was the area of a square or a rectangle?
Length times width.
Length times width, right? Okay, but now we're bigger, right? And we know more stuff. So instead of thinking about length times width, we're going to transfer these into words like the area is B times H. What's B times H mean?
Base times height.
Exactly right. So we're going to change the words into these two words because, like I said, we're smarter now. All right? Now, what's the main thing that I have to look for in order for this to have a base and a height?
Size. They have to connect.
Okay, and I got that. What else? What is a height, really?
Tallness.
The tallness. Okay? And how do you know that it's the highest portion of the whatever?
Up.
It's the biggest number?
No, not necessarily.
Like the light goes up.
Because if it's a right triangle and I'm measuring the hypotenuse,
Vertical.
right?
It's vertical.
What does it have to form in order to have a height?
Right triangle.
A right triangle. Exactly right. Or a right angle at least, right? So, we're going to introduce a word, instead of saying the height sometimes, They might use this word right here. Where have you heard altitude before?
Mountains.
Mountains, okay?
Geography.
Geography in mountains or something. What else? Airplanes, right? What altitude do we fly at? So the altitude just means a height. So from here on out, those two words are synonymous and can be kind of interchanged. But what's important now is, what you got to get into your mind is what Caleb came up with, is that your base and your height always have to make a right angle. What do I know about a right angle? It's 90 degrees. And how do I tell everybody in the world that I got a 90-degree angle? A little box. So here's my question to you. Does this parallelogram right here have a height?
Yes.
No. Yes.
Yeah.
Well, that's what I'm confused about.
Why do you say yes, Mr. Kulik?
Because I did this lesson and on
Why did you do this lesson?
you know what we were supposed to do 2 lessons? I accidentally did this lesson instead of that one. So it has a height because they like put like a dotted line, right triangle there, and then it has 90 degrees. It goes straight up, and that's your height.
And where did they put that height at?
The right side.
The right side.
Yeah.
Is it always on the right side?
Well, it can be, but it'll be upside down.
So you can't have an upside down height?
No.
I'm not the same height if I'm hanging upside down?
No.
Really? I
Wait.
shrink?
Wait, no.
Because I'm hanging
You're-
upside down, I shrink.
No, you're the same height no matter what, but it's just upside down.
I'm confused. Because doesn't that have a height, but it doesn't have a right triangle?
This has a height? Where's your height?
I think so.
You think so?
I don't know so.
Why wouldn't it? Why wouldn't it?
Okay, so where's the height?
It's not there. You can't see it because there is no numbers.
Yeah.
Easy.
The 2 arrows.
Now it is.
Your area is 8.
My area is 80?
No, it's not.
You're wrong.
Why can't it?
Because it has to be
Alex?
straight up and down.
Can't you all like make it 3D?
That's why they have a right triangle. That's why it's probably like.
Say it again?
Can't you make it 3D to find height? Not.
No,
No, 'cause
they
that's-
have like a triangle and then like that's and
Okay,
then
so normally now, this is like 95% of the time, when we have an altitude, it's drawn from a vertex. What's that mean?
Which one?
Where 2 lines meet, a point, right? To the opposite side. Making a 90-degree angle.
What do you mean?
So, where's my vertex here? Mr. Kolbeck wants to do it on the right-hand side, he said. So I'm going to start at my point. This is a point, right? And I'm going to draw a line, okay, an altitude, to the opposite side, making a 90-degree angle. So how do I do that?
make a triangle, right triangle.
I'm going to draw it straight down here, and then I have to extend out here, and look, now I make my box. Does it really matter where I measure the height from? Okay, so I could do this, or would you agree that those 2 dotted lines have to be the same thing?
Yes.
Because it's still measuring the height. And honestly, I really don't even have to go from a vertex. I could just draw this dashed line right there and put a right angle, and all 3 of those dashed lines should be the exact same thing, right? So if I told you that your height was 7, now we're going to do base times height. So what's my base?
No.
No.
It's how long the thing expands or how long it's shortened.
Okay, so there's a thought. Did you hear what he said? He's saying it's this part right here. All right? So when we talk about a base times a height, they always have to make a right angle. What made a right angle with my height? With my dashed line?
The triangle. The dotted line. No.
What made a right angle with this dashed line right here?
The line.
Which line?
The bottom line.
The bottom line, right?
Yeah.
Does 10 have anything to do with it?
No.
No.
Not right now, right? Not right now. So remember, this is the important part. You always have to look at where the height makes a 90-degree angle. It doesn't matter if it's outside or inside. So if I'm going to find my area, remember now, the capital letters versus the lowercase letters are really important. This is a capital A. Areas is always a capital. Is my base times height. What is my base? 8. What is my height? 7. So what's my area? 56. And then we should have some kind of number. Inches.
Inches squared.
Inches. Inches. So we have inches squared. So here's a question. This is where I kind of already said the answer to this. Does this little piece that Mr. Kovac included or added on to get to my right angle, does that count as a part of my base?
Yeah.
Depends.
Depends.
If you take the left side, if you just take that off and act like you're moving it over to the other side, then no. You wouldn't be taking it off technically.
But technically, what? So when I did my calculation right here, did I include this piece?
No.
What does the 8 inches actually include? The solid piece, or the original base, right? So does that extension matter? No. The extension matters to make the right angle, but the extension doesn't calculate into your area. Is this a part of the figure?
No.
No. See, so it doesn't make any difference. That makes sense? Okay? So, okay with that? Area equals base times height, and it has to be a right angle. Number 2, a triangle. Because we're used to old school, little kids way, thinking that every parallelogram back in the day was a rectangle, right? What would I do to that rectangle to get a triangle? Slice it in half, right? So if I made my diagonal this way, and then I erase the part that I don't want to see, would you agree that I still have a right angle here?
Yeah.
And so my base and my height, did it make a right angle?
Yep.
Okay, so my area is still going to be that base times that height, but what did we do to our base times our height?
Divide by 2.
We divided by 2. And why did we divide by 2? Because basically we took a square and cut it in half. Right? Now, before you ask your question, this right here is the same thing as that right there. So dividing by 2 and taking something multiplied by 1/2 is the exact same thing. But again, the same rules apply. My base and my height have to make a right angle. That's how I know where to look for my base and my height. All right, so again now, if we have a triangle like this, and they give us these numbers, do I have a base and a height right now?
No, you do not.
I do not, right? Because I do not see a box in this problem. So how do I get my height again?
Same thing.
Same thing, right? So some of the triangles are going to be given to you that show your base and height. Other times you have to draw them in. So my height here is, I don't know, 7 centimeters. So is the 8 ever used?
No.
The 8 would be used only if they went back and asked you for the perimeter of the triangle. Okay? So, what am I going to use? Now, again, does this piece count? No, right? We're only concerned about the part that is solid. So, what numbers would we use to find the area? 6 times 7, right? So, A equals 6 times 7 divided by 2. So, what's 42 divided by 2?
21.
21 what?
Squares.
Centimeters.
Forgot the 21. Right? Okay, does that make sense? Everybody good with that?
If you had like a whole triangle, like the first triangle, if you added the other half to it, then you don't divide by 2, right?
Right, then it's a rectangle again. Yep.
Like, if you have like the right angle, like with the right angle, sides. Like a s-
Well, you can do it that way. Because realistically, depending on if they ask you to find the whole part of it or half of it. Yep, yep. Okay, are we good with that one?
Yeah.
All right. The last one then that we're going to talk about today is a trapezoid. What's a trapezoid?
Things with a thing.
It's a one set of opposite sides of parallel.
One set of opposite sides are parallel. Remember, we had our traditional trapezoid that our elephant's going to stand on, right? And then we had the funky one that nobody really thinks is a trapezoid, but really is. Right?
Side of the triangle.
Okay? So, remember now, what are we going to do? Let's just say that I would come back here to my trapezoid that we're used to, and I draw this. What did I draw again? A rectangle, right? I drew a giant rectangle. And in that rectangle, what would I have?
290.
If I went back and erased that triangle, that rectangle, and I did this, what would I have?
Two right
Two triangles.
I'd have two triangles and
Square.
a
Rectangle.
rectangle, right? We don't want to call this a square yet because why?
It doesn't show.
Doesn't have a box, right? We don't know that the sides are all congruent. So it's definitely a rectangle, but it could be a square if we measure the sides.
Oh, I just know how to do it.
Okay? So, would you agree then, when I drew those dashed lines and I put a box there, that was my what again?
Right.
What did I make here again?
Height.
A height, right? So, again, look, we still have a basic height. Now, here's the difference. If I was doing this, what would I do in order to find the area of a triangle again? Base times height divided by 2. If I was doing this, what would I do? The rectangle. Base times height, right? And this one over here I would do base times height divided by 2 again. So somehow we have to incorporate all of that into one formula. So my area is going to be, how many bases do I have?
2.
2. I actually have one up here and one down here, right? The segments that are parallel to each other are my bases in a trapezoid every single time. So we have to differentiate between those two bases because I want to call this a B and I want to call this a B. So how do I differentiate between them? I'm going to use my subscripts. Remember those? So I'm going to call one B sub 1 and one B sub 2. So if we take everything that you just told me about your areas and put them together, we're going to say B sub 1 plus B sub 2. We're going to add them together and basically take the average of them. So we're going to divide that by 2. And then we're going to take the whole thing. What do we still have to take it times? A height. Now there's a lot of ways you can write this. Okay? So you could write it like that. You could write it as 1/2 h times b1 plus b2. There's a lot of different ways you could write it. But all are the same exact thing.
I had this on my Iowa assessment.
You did? Did you get it right?
I don't know.
So, here we go. Let's go to the other one and use this. And I would say that this is 4 inches. This is 8 inches. And my height over here is 6 inches. How do I know that's my height? Because it still made a 90-degree angle, right? Okay, so what's my formula? A equals
4 plus 8
4 plus 8
divided by 2.
divided by 2
Times 6.
times 6. So what's 4 plus 8?
12.
12 divided by 2?
6.
6 times 6?
36.
Why did we do it in that order?
Because
Because we
parentheses
do
are
whatever the
first.
parentheses first.
Because we have to do it in the order of operations, right? In the order of
You
operations.
can still take 1/2 of h.
But you could take the 1/2 of h. You're right. So again, you can kind of write it in different ways and you can actually do it in a different order. So you don't really have to follow the order of operations. What time are we at here?
16. I think.
Yes, great.
Okay.
So on the other one, the 1/2 h.
Yep. This one?
Yeah. You would do your bases first.
Yep.
And then for your height, would you
take that times the 1/2, or would you?
Either way, doesn't matter. Because then they're all being multiplied together. So it doesn't matter the order that I necessarily do. Okay? Questions there? Any other, are you okay with those? Do you want to see more examples of those kind?
Yeah.
What? Yes?
One more.
Which kind?
Trapezoid.
What?
Trapezoid.
The trapezoid. Okay. So, trapezoid is going to have this. Now, the other thing as I'm writing this one down, what you really need to make sure of is that when you do these problems right here, that they give you the same label throughout the entire problem. You understand what I'm saying there?
What if they don't?
If they don't, then you gotta turn it into the same thing. So what I'm saying here is this. If they would have for some reason in this problem right here said this was 6 centimeters instead of meters, then I have to go through and I have to change all of them into the same thing. It doesn't matter which way you change them. Okay? You just have to make sure that you change them into the same thing. That makes sense what I'm saying there?
Yep.
Okay, so what am I going to do here? Go ahead. Try it out on your own. Now remember, if you don't like fractions, what do? Turn them into decimals, right? What's 1/4? 0.25, right? And what's 1/2? Hopefully you know 0.5.
How many centimeters are in 1 meter? 100 yards.
No, 10. 10
No, there's
centimeters. What?
There's 100 centimeters in a meter.
No, in a meter, yes. You're not going to have to do that. It's not centimeters. I just said it, if that ever happened, you had to do that. Here's another way that you can write this. I can also write it like that, right? That means the same thing.
Or
I gotta
Nine
read.
divided by two.
Oh wait, I multiply.
I think I got it.
So, continue to work, but if you are done, look up here and notice that I can go through the order of operations exactly like they tell me to. I go through here and add, and then multiply, and then divide. I could take 6 divided by 2 first, and then take 3 times whatever I get on the inside. I could distribute that 6 through there, and then add, and then divide. I can do this problem a lot of different ways, and I should get the exact same answer. What you come up with?
38.25 squared.
38.25 meters squared. So again, then at the end, make sure that you look to see what you're supposed to round to,
Are you supposed to turn them into decimals?
and then you can turn them into decimals or leave them as fractions. Okay, that doesn't matter. Okay? Everybody good with that? Okay, Mr. Connect, see what we did? All right. So again, just make sure that you see that they always make a right angle. Where they make a right angle, that's what you're going to use for your base times your height. Okay? Now there's going to be something called composite figures in this too. What's that mean to you?
Like they don't work out.
No. What's composite mean? Composite means basically they built it or they put things together. So if they have a composite figure, what you want to do in that is you want to break it down into individual things that you already know. So basically they're going to give you a shape or a figure that's kind of a weird shape. So all you're going to do is basically, like this trapezoid right here. you would start drawing lines and turning it into things that you could actually take the area of. So you'll know that you're going to do this because you don't understand how to do the whole area of the shape that they gave you.
Doesn't high school use composite bats?
Composite bats, yes.
Yeah, bats.
Okay? So, there's a couple of those, I believe, on the assignment. So don't get frustrated and work through them slowly. But we'll look at a couple examples of this